Welcome to Mining Review Africa, and today we are speaking to Mark Baller, who's the Managing Director of Weba Chute Systems. Mark, thank you very much for joining us today.
Oh, thank you for coming.
Okay. Now, Weba Chute Systems has always maintained that not all chutes are created equal. Why do you take this position, and what are the potential risks or consequences on relying on standard or generic chute designs in the material handling operations?
Well, the transfer chute has always been underestimated in the complexity of the operation of the chute. And the reason for that is every configuration is different. Every operation, the material characteristics, the climatic conditions, there are differences. So it's not a plug and play application where you can just take a standard piece of equipment and plug it in somewhere else and think it's going to work. So what the approach that Weba has is very much along the lines, we look at each application as a unique application. We look at the operating requirements, the material conditions, the transfer configuration, and we then do a bespoke design to meet the client's requirements so as to give them the best possible result. The danger of trying to use generic type designs and just plugging them in, there's obviously a cost saving on the initial side, but on a performance side, you are always going to sacrifice performance, whether that be the efficiency of belt loading, the dust generation, the environmental noise pollution, or it's high wear and tear, higher maintenance costs, shorter maintenance intervals. And all of those factors can be extremely costly to the operation. So going for a bespoke design that is custom to a specific application while being slightly more costly initially, in the long run will pay benefits.
Okay. Now, Mark, let's look at your engineering process that you have. There's a strong emphasis on discrete element modeling. Can you explain how this technology supports performance optimization?
Well, it's actually interesting. In the industry, DM is widely used and as a design tool. And DM by nature is a simulation software which simulates a design that has been done. So it is not actually a design tool, it's a verification tool. And a lot of people are trying to design using DM, and there are ways of doing it. But what we use DM, and we use DM quite extensively, is more of a verification of our design and to show potential flaws or issues that the client may have so that we can tweak our design to give the client the best possible solution. So we use it extensively, costs us quite a lot of money, and our clients often requests the DM because for them it's a verification of the design, so it's a due diligence. But we have our bespoke design criteria and principles that we follow, which we have developed over the 5,000 chutes we have done. And with each application being different, experience and practical know-how plays a huge part in the success of our designs and the information that we get from our clients, because we can't design in a vacuum. So we have to get valuable information from the clients. If the clients give us incorrect information, that will mean that the design is then based on flawed information. So that partnership between ourselves, our clients, and then the software like DM and our design software and everything else is enables us to then give the client the best possible solution.
Okay. Now let's look at your experience and expertise. Weba Chute Systems has installed over 5,000 chutes globally. What have been some of the more challenging or unusual applications that you were tasked to do, and how did you manage to turn these into a success?
Well, growing our business within the Southern African region, a lot of the material is very similar in nature. Your iron ore is iron ore and your coal. There might be slight variances, but what we found when we went further afield, like into Australia, is the iron ore in Australia doesn't even look like our iron ore. It actually looks like something that you dug out of your garden. It looks like dirt, and the flow properties are vastly different from what our experience in South Africa was. So when we started doing shoots in Australia, this was one of the challenges we ran into, that by nature, the material was more cohesive, stickier than the iron ore that we found here. So we had to come up with solutions, and on one large project that we did, I mean, with this included having air cannons to break off build-up, looking at the angles that you design the chutes at, whereas South Africa, we may use a particular flow angle because it's suitable for the material. There we had to look at something different. And in many applications, you then have to move away from our standard cascade type design chutes, and we have to go and look for suitable liner applications because the material is just not going to flow on a material scenario. So you run into those kind of applications. And then we went across the United States and we ran into something. We were doing an application for coal, and it was -2-inch coal, or for -50 millimeter coal. And we built the chute, and then they said, but this is on a barge offloading system. They get chunks that come through the size of a Volkswagen. And we said, what do you mean? You specified 50%, -50 coal.
Yeah.
And now they get lumps that come through that are literally 1.5 meters. It's all these little 50 millimeter particles that in the barge, because there's moisture, coming up the river in the middle of winter, have frozen together. Wow. And that's a frozen chunk. And obviously coming from South Africa, we had never heard of a frozen chunk. So that was quite a learning curve, where it was now, if you're dealing with a barge unloading system, the size the client gives you, it's very important. We ask for what is the average lump sizes and what's the maximum size. And they stipulated 50 millimeters or 2 inches. Yeah. And obviously there's a big difference between 2 inches and 1.5 meters. And our chute was just way too small for the 1.5 meters. So we had to revisit that application. And then you go even further north to Wyoming and into Canada, where it is so cold in winter, they now have heat tracing and heating pads on chutes because the material literally freezes, within the chute. So there are so many interesting applications that we run into, and every one of them is a challenge. And, touch wood, to date, we've learned from those experiences, and we've adapted designs to suit the different conditions. But yeah, those are some of the interesting things we run into.
Wow, that's really interesting, Mark. Now, Mark, let's turn our attention to brownfields operations, and Weba Chute Systems is regularly retrofitted into existing and often space-constrained operations. How does your team go about designing solutions for these environments without requiring major structural change?
Well, the brownfield applications, or as we call them, the retrofits, can often be the most challenging because you are going into a pre-established configuration. And unfortunately, sometimes the engineers in we've been into plants that date back to the 1920s, but those engineers didn't consider the tonnages that were going to be put through. The plant has been upgraded and the structure has remained the same. So, as good as Weba is, the laws of physics still apply to us, and we have to apply those in our designs. So you go into a retrofit. First prize is to get a chute to work that is going to work in an acceptable manner without making changes to the configuration, because we know that any major change is going to be extremely costly and maybe make the project unviable. Whereas some minor changes, if you move the pulley along the belt line a couple 100 millimeters, or minor modifications can be done. but it is always challenging in that. And if the configuration is bad, what our approach then is we come up with the best possible design we can do in the existing configuration. We spell out to the clients the drawbacks or the negative points of that design and expected performance related issues. And we then look at the most cost-effective upgrade to the configuration, if you want to call it that, where with minor changes, we can give them a better solution. So from our point of view, we end up doing 2 or 3 designs instead of 1. So it costs us money to do that. But it has always been our philosophy that we're not just trying to give the clients a slap bang solution. We are trying to give them the best possible we can. And sometimes you have to offer to the client that if you take on this additional cost or do these additional changes, this is the improvement in performance you can get, because it would be negligent of us not to offer that to the clients. So we go the extra mile, we do the multiple designs, we end up running multiple DM simulations so that we can actually show the differences and what have you. But at the end of the day, it is going to be the client's choice whether they want to do it or not. And unfortunately, in many cases where the client chooses not to go with our recommended changes, the result is as we predicted, and the client is then not actually happy with the results. And we've even been to the case where after many meetings with a client, where we tried to convince him, he refused and he went with the lesser option. And when it worked, when he got the result we told him he was going to get, he said, "But you should have convinced me that I must do the changes." But we tried, but in a lot of operations around the world, as soon as you start changing configuration, that's a no-go. So sometimes we have to do the best we can with what we have, but we will always try and offer the client an alternative, a better solution if there is one possible.
Okay. Now, Mark, modular construction is a key feature of your chute systems. Tell me, how does this approach improve performance and, most importantly, safety for those working in high wear areas?
Well, there's a number of ways in which we look at modular design. Obviously, when we design a chute, the first thing you're looking at is accessibility into the plant. You're looking at the ease of installation, safety of installation. So you have to design the chute in such a way that it can be safely installed by the contractor or the mines personnel, so that to avoid injury, and that it can be easily installed. So that's the one aspect of it under design that you look at it. Then when it comes to the actual maintenance of the chute, we look at the maintenance components, whether they be our lip liners or the actual liners of the chute. We look at access to the chute. We've come up with some innovative methods of giving people a safe way of doing maintenance. So we have, for argument's sake, on our lip liners, we've over the years made the segments smaller, so they're easier to handle, because when you're working in a confined space and you get given something that weighs 25 kilograms, it's very difficult to handle, and potentially you can crush your hand or what have you. So we look at trying to make the maintenance components more manageable. So this brings in our quick release lip system, which are now individual blocks, which are much easier to fit. They literally just swing in under a pin, and it shortens the maintenance period, but also the guys doing the maintenance are now working with items that weigh a maximum of 5 or 6 kilograms versus a segment that can weigh 20, 30 kilograms. So we look at all these things. At the end of the day, the safety of the people maintaining the chutes is of utmost importance to the clients and to us. We don't want people injured or hurt maintaining our equipment. So we try and make accessibility good. We try and give them a safe environment in which to work, and we give them components which are manageable without needing a lifting gear.
Okay. Well, finally, Mark, in your experience, why should operations view the chute as a critical performance component and not just another standard commodity item? What is the long-term value if you adopt this mindset?
Well, I think the mindset has been changing over years. If we go back 20, 30 years ago, the chute was a box.
Yeah.
And that's all it was seen as. So when you came to them and said, we offer an engineered solution, they go, what are you talking about? It's a box. Whereas I think with technology and with time, what we have seen is clients are becoming more aware of what the cost implications of a poorly designed chute are. Now, this can run into, so we start with a simple one, which is spillage. So now you've got to have people employed who have to come every day and clean up spillage, and that material needs to be put back onto the conveying system. And that's a cost associated with that. Then as we've moved into environmental areas, the noise and the dust play a much more critical part from the health and safety point of view. So now the mines have to look at dust suppression or ways of mitigating dust. So now there's a cost of operating dust extraction or dust suppression. So, all of these factors that as you go along, they just add to the cost of the chute. And then one of the biggest ones, we have clients and we tell them, well, this is a relatively large chute. It's going to cost you X amount of money. And he goes, well, that's ludicrous. But if his plant stands for an hour, they lose millions of rands. So if you've got a chute that is poorly designed and you are losing 2-3 hours a week for blockages or for cleanups or for unplanned maintenance, that is costing you millions and millions of rands. It actually makes the cost of a properly designed chute irrelevant, because it's literally on the savings that could be free because of how much you would be spending on a poorly designed chute. So the important thing here is to recognize the cost. So it's abnormal wear and tear to your conveyor. It is dust, it is noise, it is spillage, it is high maintenance costs, it is unplanned stoppages due to blockages or unplanned maintenance. So all those factors make the chute actually one of the most expensive components in an operation if it is a poorly designed chute. And it can literally cost the operations millions of rands.
Wow. Well, Mark, it's always great chatting to you. Thank you for your insights and for joining us on Mining Review Africa.
Yeah, well, thank you very much. It's good to see you again. Thank you.